Hey everyone, so in today's video I'm going to be explaining what an isotope is and why it matters in chemistry. And on top of that, I'll be talking about how to recognize or calculate isotope related values. So firstly, what is an isotope? So isotopes are atoms of the same element that have the same number of protons but different numbers of neutrons. And as a result, they have different masses. So key characteristics could be like isotopes, all isotopes of an element have the same chemical behavior. But we have to remember the mass number changes because of the different neutrons. And on top of that, although they have the same chemical behavior, some isotopes are stable while others are radioactive. So let's go over an example. Let's take the carbon isotopes. All carbon atoms are going to have 6 protons, but carbon 12 has 6 neutrons, has 6 neutrons. While carbon 14 has 8 neutrons. They're both carbon, they're just different isotopes. Let's go over now the different notations for isotopes. So we have the hyphen notation and we have the nuclear notation. So if we go over the carbon examples again, this is hyphen. Nuclear would be if we were to do, we can do carbon again. So the top number is the mass number and the bottom number is the atomic number. Now, this would be the same for all isotopes. So the top number for nuclear will always be the mass, and the bottom number will always be the atomic number. Now, why do isotopes matter? They're used in radioactive dating, like carbon-14 dating, so we can see how old certain fossil fuels and things like that are. Or fossils, I should say. Some are used in medicine, so we can take like cobalt-60 for cancer treatment. And isotopes also help calculate average atomic mass on the periodic table. Now let's go over some practice problems. So let's say, how many protons, neutrons, and electrons are in carbon-14? I'll give you a second to pause the video and look that up in the periodic table, but carbon-14 has 6 protons. It has 6 electrons, since it's a neutral atom. And it has 8 neutrons. And we know that because it's 14 minus 6, which equals 8. So 8 neutrons. Let's go over another question. Let's say oxygen-16, an isotope of oxygen-17. Is oxygen-16 an isotope of oxygen-17? Why or why not? Now, think about that for a second. The correct answer is yes. They're both isotopes of oxygen. They have the same number of protons, just different numbers of neutrons. Now, it's really important you remember that. Isotopes just have different numbers of neutrons, but their atomic number, the number of protons, are the same. Now, let's go over nuclear notation one last time. If I give you, let's say chlorine 35 and chlorine 37, what would their nuclear notation be? Pause the video and write it out on your own first. But when you come back, you'll see that the nuclear notation for chlorine 35 would be 35 over 17 Cl. And then for chlorine 37, it would be 37 over 17 Cl. We need to remember that the mass number is always on the top, and then the atomic number is always on the bottom. So as a quick recap, isotopes are simply the same element with a different number of neutrons. They have the same protons, they have different mass numbers, they have the same chemical properties, and they're important in dating, medicine, and atomic mass calculations. Thank you.